So today we're going to talk about domain and range. Domain and range refer to graphs. We can find this in coordinates, tables, mappings, real-world situations. So this is something that is not going to go away. We will use it all this year, and you'll use it in Algebra 2, and if you go past that, you're still going to see it. So things I want you to know about domain. Domain refers to the x values of whatever we're talking about. Other words that are synonyms, right? Synonyms are words that mean the same thing, right? Independent. You should have remembered that from science, right? The independent variable is always on the x-axis. And input, we talked about that one when we were doing function notation. Range refers to the y values, the dependent variable, and the output. So there are two types of domain and range. Today we are focused on discrete domain and range. And I want you to notice that discrete starts with a D. And I want you to realize that this is going to be, if it's on a graph, it's going to be dots. D for domain, or D for discrete, and D for dots. Okay? You're going to find that when you see the dots on a graph, we're not going to refer back to being 3 years old and connect the dots. We will not connect the dots. Okay? Data that is discrete is countable. So what I mean by that is you can count how many classes you have been to throughout the day. We've been to first period, 1. We've been to second period, 2. What if it's the very beginning of the day? How many classes have we been to? None. So could I say technically, so far today you have been to 0 at the beginning of the day, you've been to 1 class, and then you've been to 2. Okay. If you are lifting weights in the gym, right? The number of plates you put on the bar, right? You can count those. The number of questions on a test. There's actually 14 questions on our test next week, right? So as you have finished them, you can say, I've done 0 questions, I've done 1, I've done 2, I've done 3. These are all countable. So I want you to realize that we are not, there are no halves. No half numbers in this, okay? We're really not ever going to have any decimals when we do this unless it's money, okay? So what I mean by that is you can't go to 1.5 classes, all right? On a graph, this is going to be dots. Do not connect. We really, really want to. See what that picture means. Don't connect the dots. Okay? Those are just individual coordinates. Okay? We're not going to have any connecting of those things. When we represent discrete domain and range, domain is the set of what kind of values? What did we say? X values. And I want you to notice there's this little brace here, these little squiggles. If you can't draw the brace, you can draw a squiggle, and you're going to list all of your numbers. So notice that all of those numbers are individual. We are going to list them. Very important, because if I wrote that maybe it's the end of the day and you wrote I went to 0 to 7 class periods, that implies that we have like half a class, and we don't. Okay, we want to list those numbers individually. Tell me about the range. Range is our set of what? Well, very nice. And again, we are listing these. Tomorrow we'll look at a different method. Key here, the numbers are listed from least to greatest. And we do not repeat our numbers. Do not repeat our numbers. Find the domain and the range of this table. So again, domain and range, where do you want to start? You want to start domain? You want to start with range? The range? The domain? Okay, and one of the things that I would suggest you do is domain is what? Domain is what values? X. So I usually just go ahead and I just put an X there when I see those words, so that triggers in my head, oh yeah, I'm looking at my X's. Oh, well, look right here in the table. Oh, it's so nice and pretty for you. We're going to draw our brace. And again, if you can't draw the brace, draw a squiggle. Tell me my x values in order from least to greatest. What do we got?
-5.
Keep going.
-2.
Keep going.
0.
Okay.
3.
Good.
6.
There you go. And we're done. It is a function y. X does not repeat. Very nice. And you're going to actually do that on your practice today as well. We're going to review that. What about the range? Range means what? Y. So, oh, here's my y's right here. Now be careful. We need to make sure we write them how? Least to greatest. What's my least? -23. -14. -8. 1 and 10. So this one was nice. It was already in order for you. Sometimes it is, sometimes it isn't. Here's another one. So now you need to be able to do this in multiple ways, right? So I gave you a table a minute ago. Now I'm going to give you some coordinates. So let's start with this. Is this a function? What are you looking at if you're looking at, is it a function? It is. Why is it a function? The x does not repeat. So yes, this is a function. Good job. No repeating x's. Do you want to start with domain or range? Domain means what? X. Tell me about my x's. Remember, least to greatest. Keep going. -2. Good. Very nice. Great job. Great job. Range is y. Very nice. And, oh, be careful. This one is not in order, but we need to put it in order. What's it going to go first? Good. 1, 3, and 4. So again, it's not always going to be in a nice, neat order for you. If it's not, you can very well put it in order. Good job. Let's look at a graph, and then we'll look at a word problem. So here, oh, we have dots. I want you to remember, dots mean that we need to list. We are not going to connect the dots. Is this a function? Yes, it is, because if we drew our vertical lines, it would only touch the graph one time. So if you wanted to see that, look, once, 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 okay? Now, when we talk about our domain, we're talking about which values? X. Now, you can do this a couple of ways. You can look at our vertical lines that we just did and we went through these X numbers. You can do that. Or you could also make a table of values. We could come over here and we can say our coordinate is at -4, +5. We're at -1, +1. We're at 2, 4, we're at 3, -2. So if you wanted to make a table, you could. Or if you wanted to just look at, all right, this dot is at -4 on the X. This dot is at -1 on the X, which is how we put it in the table to begin with. So you have a couple of options here, 2 and 3. Okay? So that's how you can do your domain. We can do the same thing on our range. You can look at your table if you made your table. Okay, remember that your range is your y. Okay, so your range is going to be, now, let's do this. Let me undo that. We need to go least to greatest. So on a range, instead of left to right, we're going to go bottom to top because our lower numbers are on the bottom. -2, +1, +4, +5. Now, again, if looking at the graph and drawing those lines is confusing to you, I would strongly suggest you just make your table so you can see that, in fact, we did -2, 1, 4, and 5. Last example is a word problem. Mario's Pizzeria has you build your own pizza menu item. The pizza has a fixed cost of $11.50 plus, I'm going to put a big plus sign there, an additional 55 cents per topping. What does per tell us? Each. Multiply X. So really, when I do that, I can now see My equation is 1150 plus 0.55x. We could even write y equals, okay? So you should be able to write an equation from a word problem. You've been doing that since 6th grade, maybe even 5th. It tells us, what is the domain and the range for the cost of a custom pizza? Oh, this is important right here. X is the number of toppings. Is domain X or is domain Y? Domain is X. So I'm actually going to write here, and I'm going to put X, and I'm going to write toppings. So I know that those match. And Y is the cost. So down here on range, I'm going to put Y with a dollar sign. It's very important that you're labeling so you understand what you're looking at. This other sentence says that the restaurant will allow up to 6 toppings. Up to 6 toppings. So is that going to deal with our range or our domain? The domain, yes, because it's toppings. So if I want to get a cheese pizza, how many toppings is up? None. What if I wanted to put pepperoni? That's what? 1 topping extra. What about black olives? How many toppings do I have now? 2. And pineapple. 3. And sausage. 4. And ham. 5. And maybe onion. 6. So if we know the domain, 0, 1, 2, 3, 4, 5, 6, and we have this equation, 1150 plus 50.55x, can we write our range? Okay, so we have x's, right? These are our x's. So what if I put 0 into my equation? If I got no extra toppings, if I got just a cheese pizza, how much money did I spend? $11.50. So this was that, we talked about no halves except in money, okay? What if we got 1 topping? How much did our pizza cost? What are you going to do? We're going to add 50 cents to it, or 55 cents to the $11.50, and we get, I heard someone say $12.05. What if we got 2 toppings? 12 what? $12.60. And then 3 toppings? 13 what? $13.15. And 4 toppings? $13.70. And 5 toppings? $14.25. And 6 toppings? 14 what? 80? So what's the most we could pay for that pizza? $14.80. Okay. Now, sometimes they'll give you this in a table, or if you wanted to make a table, it might be a little easier to see. But you need to be able to distinguish between domain and range.